Hello.
Yes. Good afternoon. How are you all?
Good evening, sir. Yeah,
Sir?
fine, sir.
Very good evening.
So easy, sir.
How was the paper?
Yes, it was so easy, sir. I answered literally everything, sir.
That's great. So I think that the last class, if you have attended that, then I think most of the questions were from the last lecture, right?
Yes, sir. Sir, yes, sir.
Exactly.
Sir, what is
In
unhydrated substances?
yes,
What is unhydrated substances?
we will in this today's class we will discuss the question paper, whole question paper. You have not to worry. Okay.
Sir, but I'm just asking a question, sir. Is what is unhydrated substance?
What is?
Unhydrated substances.
Anhydrous means which do not have water molecules. That
No,
means
sir.
water of
Hydrous, no, sir. It's anhydrate.
hydrated means which do not have water of crystallization, and hydrated means which has water of crystallization.
Oh, not anhydrate. Sorry, dehydrating agents. Sorry, sorry.
Exactly. Dehydrating agents are those which actually remove water from other substances. Okay, I will just explain each and everything.
That's the same
So
as
first
drying
of
agent, right? Oh, drying agent removes
Hello.
water crystallization, and dehydrating agent removes water.
there is difference between the drying and the dehydrating agent. I will explain it in today's class. Not to worry.
So drying agent removes water crystallization molecules, and dehydrating agent removes water.
Hello.
Exactly. That removes H2O from any substance. That means that removes only H2O. Okay, let me
So, but you
first of
can't teach what a dehydrating substance.
I think then it is left. Have I not taught in the last lecture?
Maybe you said to learn, like maybe you can easily learn this answer that part alone. I don't know. Sir.
Okay, first
Maybe
tell
you
me,
might have.
is the
Yes, sir. We
screen
can see the
visible?
screen, sir.
Okay. So first of all, let me here.
Turn on your video, sir. Sir, am I audible?
Yeah, you are audible. So can you see this? Okay, let me share first the question here.
Sir, we all have the question paper in our hands, sir.
You
So
are
we have
having question paper with you.
Yes, sir.
Okay.
to scan. Okay. So can you?
So can you flip your screen?
It's already flipped.
Yes, sir. Now
Now
it's
it's
fine.
flipped, sir.
Okay. So can you see here this question?
Yes, sir.
Okay. So see here, our first question, it was just that soap is chemically a sodium salt off. So I hope that you remember, I have already taught in the class that this soap, it is
Stearic.
actually exactly, it is the sodium salt of either sodium
You said
stearate
it
or
was sodium
exactly sodium.
stearate.
Exactly.
C
Okay. So that
starting with
means
COONA.
question number first, it is correct option will be your D. That is your stearic acid, right?
Yes, sir.
Exactly, stearic acid.
13 H35COONA.
So can you just give me the examples of soaps? So one is your sodium
Sodium
palmitate.
stearate, sodium palmitate, sodium olerate.
Exactly. So we are having sodium palmitate and similarly sodium stearate.
Sodium
You
olerate.
didn't ask for examples, sir.
Yeah, they
And
only ask like the question
no,
that
no,
two
you
marks.
have to only just mark here the option. So the correct option will be your option D, right? That is stearic acid.
I'm learning that. They'll ask either of them, or either three of
Sodium oleate. Okay. So next was your that 4 liter of an organic compound acetone is
I
present
got
in 9.
something like 4 point something, sir.
I got
Exactly, that's correct.
4.25%.
4.4 will be correct. So let's
So I
see
got
here how.
4.25.
I got 4.48, sir.
See, okay, I will tell
I
you.
don't
Uh,
remember
we,
what I got.
we are having here acetone. Acetone is given 4 liter, right?
If I
Yes, sir.
write 4, is it still correct,
Yes,
sir?
sir.
Acetone is given 4 liter.
Uh,
We have already learned this how to calculate the percentage, and similarly it is given you that the solution is having 90 solution, its volume is 90 liter, right? Now when you just calculate the volume percentage, what you do, we just divide this 4 liter, that is the volume of the solute is here, you are
90%.
exactly
Did they
upon
give the
90
marks in the thing?
No, we don't. I mean, yeah.
into 100. So 0 and 0 it will cut, so we are having 40 by 9. So that means it will be now 9 threes are 9 fours are exactly, it is 9.
So it'll
So
be 4.4.
4 exactly,
Hello,
it will be
sir.
Less than the mark
4.44, right?
4
It will
or
be
anywhere close to
4.44,
4.4.
uh,
Sir,
right?
Yeah, I got
sir, like
4.48.
So
if I get anywhere close to
exactly,
that less
you
than
will
that
get the
mark,
mark.
like 4.25 or something.
If you are writing 4.4, you will get marks. If you are writing 4.24, then you can also get marks because it's approximate, correct? Okay, so the next was here and that,
Friends,
so what was the next here?
Deliquescent and hygroscopic.
hygroscopic
Exactly,
difference.
deliquescent and hygroscopic, we have studied this, right?
Yes, sir.
yes, sir.
So
Delic
can I write one difference and then I mean example and then still get
Sure, you can tell me. Okay, tell me one difference.
one difference is like where
So
uh,
tell me
deliquescent
about
substances
hygroscopic.
absorb, I mean, when exposed to air, absorb moisture and gets converted to a I mean, saturated solution. And then
Exactly,
hygroscopic substances, when exposed to air, absorb moisture but does not get converted to a solution.
exactly. So hygroscopic is that substance which when exposed to air, so whenever it is exposed to air, I have told that it will absorb so much moisture that it gets converted to saturated solution. So absorbs lot of moisture. So when it absorbs lot of moisture, so at that time it will definitely get converted to saturated solution. So gets converted to saturated solution, right?
Doesn't, sir, hygroscopic substances doesn't get converted to a solution.
Okay, yeah, it is hygroscopic, sorry. Yeah, they will not get converted to,
Yes.
they will not get converted to any. Okay, let me write it here that not gets
Sir,
converted to
this
any.
test was actually easier than the previous one, sir.
Exactly.
The previous was one more so easy, sir. Like, wait.
So not gets converted to saturated solution, correct?
Yes, sir.
So can you give
Yes, sir.
me the example of this hygroscopic substance?
So CuSO4 plus 5H2O gives CuSO4 dot 5H2O.
Yeah, so we are having this copper sulfate, it will act as a hygroscopic substance, right?
Yes,
Similarly,
sir.
if yeah,
Uh,
exactly. We are having quicklime, that's calcium oxide. So next was our deliquescent. So deliquescent, they always, okay, so I have exposed to air absorbs moisture.
Deliquescent gets converted to sulfate.
Exactly.
So,
We have to rub it here.
Made mistake.
So absorb. So in case of deliquescent substances, you will always remember that whenever we have any deliquescent substance, it will absorbs lot of moisture, right?
Yes, sir.
yes, sir.
Yes.
Absorbs lot of moisture when exposed to air. So whenever it is exposed to air, it will absorb so much water or moisture that it gets converted to saturated solution, correct?
Sir.
So gets converted to, so can you give me the example of this?
So,
Sir,
sodium
CuSO4,
sodium
5H2O.
hydroxide,
Uh,
potassium
yes,
oxide,
we are having
Sorry,
sodium
sorry,
hydroxide,
sorry, sorry. Sorry, sorry,
potassium
sorry,
potassium
sorry,
hydroxide.
sorry, sorry.
potassium
Sorry, I was
hydroxide.
talking about.
So two is enough, right, sir?
Okay, now see
There's
here,
one more.
one more difference. Whenever we just talk of this deliquescent substance, you will remember that it is always your crystalline solid. So they are always crystalline solids. Do you know what is a crystal?
Yes, they're
Yes, sir.
formed when hot saturated solution is cooled.
Hot saturated solution is cooled
Is
down.
cooled.
Exactly. Whenever hot saturated solution is cooled down, we get the crystal. And crystal, you will simply remember it is the pure form of substance. Crystal is always
Yes.
pure.
Yes, sir.
So crystal is always the pure form of substance. So it is always prepared whenever we are having hot saturated solution and we are just cooling down it in a china dish. Okay, then what will be these hygroscopic substances? Will they be crystalline?
Crystalline solids or crystalline
They are crystalline. They
Uh,
may be crystalline or they may be sometimes liquids. Crystalline or they can also be liquids. Correct. So this will be the difference between hygroscopic and the deliquescent. So what was the next question?
salt normally used in desiccator is
salt. Yes.
Exactly. Salt normally used in desiccator. So that will be definitely your anhydrous calcium chloride, isn't it?
Anhydrous calcium
Oh my
chloride.
God.
Yes, sir.
Oh my god.
Yeah.
That is
Okay. I will
What
write
did you
it here.
write there?
anhydrous calcium chloride only. I thought it was Epsom salt, but then it wasn't that. So
See,
all of
we
this
are
was in
I thought it was washing soda. Then I was like, okay, anhydrous salt.
no, see. Desiccator, that means you are just using the desiccating agent, and I have already told you what are desiccants, desiccating
Yes,
agent.
sir. Yes.
Drying
moisture.
agents. You
So the
simply
one
you
that removes the moisture
They remove
from.
moisture from other
exactly drying agent. You can simply call them as drying agent. So drying agent is your definitely anhydrous calcium chloride. Because when it is
Yes, sir.
actually exposed, whenever it absorbs moisture, then it actually gets converted to calcium chloride 2 times water. That
Oh,
means,
it converts into a hydrous.
yeah, it was anhydrous, so it gets converted to
If
hydrate.
you did not know, you were being.
So that is why it absorbs moisture, right?
It's,
Yes, sir.
Absorbs moisture. So that's why this will be your the salt which is present in the desiccator. Okay, then the next was,
then why a solution is always clear
Why
and
a
transparent.
solution
yes,
is always
and
clear and
why a solution is always clear and transparent.
So
So
I
can you tell
wrote
me?
because it's a true solution
So
and
because
all
it is
particles
a
are less than 1.
homogeneous mixture and also the molecules go fit perfectly between the gaps.
Yeah, see actually what happens, right? Whenever we have a true solution, whenever we dissolve salt NaCl, this salt actually it is your
It's
water
less than
soluble.
1
It's
millimeter.
it's fairly soluble. It is fairly soluble in water. So when it is actually getting dissolved, it completely dissolves in water. And when it dissolves completely, it disappears, right? Dissolves completely and disappears. So when it will disappear, so that means the water will retain its property, and that means it will become clear and transparent.
Yes, sir.
B- because actually what happens when it uh, dissolves completely and disappears, right? You can write here that it dissolves and disappears.
I got that
Well,
before.
I have written down this. It completely dissolves and disappears.
Yes, sir.
Dis- Dissolves completely and disappears. So now you had to here remember that whenever we have any salt and we are just putting it in water, we are making a true solution. Then what is the particle size here?
1 millimeter, less than 1 millimeter.
Exactly. Particle size is less than 1 nanometer. So that means we cannot see it. We cannot see these NaCl particles when they get dissolved in this water or any aqueous solution. So that means your water, it will just look clear and transparent.
How many reasons should be right, sir?
A reason should be like this, that whenever salt, that is NaCl, it is actually dissolved. We are having, whenever we have water soluble substances, they dissolve completely in water and disappear. So that means the water retains its property. What is its property? Water is always clear and transparent, so it retains its property because particle size is very
It is
small. It is less.
tasteless, color, sir. It is tasteless, colorless, smellless.
Exactly. Water, we have already discussed its property.
Orderless.
It is odorless.
Smellless, ra.
You can
I mean,
Orderless.
yeah, orderless. Sorry, sorry,
test.
sorry. I'm bad at English.
Okay, no problem. Odorless, tasteless, it is
English
colorless,
needs to learn you. Yes, sir.
it is clear, it is transparent, isn't it?
Yes, sir.
Yes, sir.
So that means a solution, it will retain its property. Water will retain its property if we are having such a salt which gets completely dissolved in it. If salt doesn't get completely dissolved, then your solution will not be transparent. You have to remember that. Correct?
Yes, sir.
Yes.
Okay. Now next is explain why the solution cannot be separated from, why solute cannot be separated from solution by filtration. So
So
what you have
because
written?
So
the
because
solution
filtration
is
is a physical method
homogeneous.
of separation, and
Mhm.
true solutions cannot be separated by any physical means, and
Yeah, I
thus it
said
is
Mhm.
not
chemical
possible.
means can be only.
Yes, sir.
Yes, see,
That's why
actually,
I asked the point saying the
in
chemical
true
means.
solution, I have told you that the particle size of solute, it is how much?
One
Millimeter.
Nanometer.
millimeter.
It is
One
less
nanometer.
than one
1 nanometer,
nanometer, right?
not
It is
Yes,
less
sir.
than
Yes.
1 nanometer. So when it is less than 1 nanometer, if you are using just the filter paper, for example, let's say this is your filter
just
paper,
go
you are
through
using
this.
it, it will exactly go through this. It will not stop here on the filter paper. It will just go through this. So that means solution can easily pass because particle size is very
They
small.
are
So that means,
chemically
yeah,
combined.
So if we
ex-
have so if we have a filter paper which can filter nanoparticles, can it then can it
That's
like
called a normal paper.
filter it?
Only
yes,
have to
yes, yes.
find that
But
one. That's not
but
there. Eh?
but whenever we have filtration, we are not having such any filter paper whose in which nano particles can be stopped. So there isn't any
Solid
such.
object can be like that.
If we
If we are
find
having
something, we can name it
Sir.
Sankalp paper.
if we are having
So
more, if we are having particle size greater than 1,000 nanometer, then they can be stopped with this filter paper.
Sir, but what we
oh,
wrote is also correct, right, sir?
Yeah, what
Yeah,
you have
chemically
written?
combined.
yes, sir.
Sir,
They
we
cannot
wrote
be
that
physically.
filtration is a physical method of separation, and true
Right.
solutions cannot be separated through physical means, and they can only be separated through chemical means, and thus it is a it's not possible. We wrote that is also correct, right?
A little bit, but not exact. See why? When you just dissolve any salt in the solution, can you tell me, is it a chemical change? It just dissolves there. It is a physical change. It is
Yes,
not any
yes,
chemical
sir.
change.
Yes.
So that means salt, whenever you put it in water, you get it is true solution. That means here there isn't any chemical change. It just dissolves in it. Dissolution, it is a physical process. You have to remember that dissolution is a physical change. It is not a chemical change, right? It
Yes,
is a
sir.
physical change. Okay. So that means the proper answer for this will be that actually when solute, it actually gets dissolved in the solution, its particle size becomes very small. It is less than 1 nanometer in the solution, true solution. So that means it cannot be separated by filtration because filter paper cannot stop these small particles which are having a size less than 1 nanometer. So that's why you have to remember that if sometimes if you are just dissolving a solute which gets partially dissolved, so that means the particle size is bigger, at that time you can separate it with the filter paper or filtration. Got it?
Yes.
So you can
Yes,
write
sir.
that if solute gets partially, if solute gets partially dissolved Partially dissolved means that particle size, it will be big, right?
Yes.
So when particle size is big, so when particle size is big, so at that time you can separate it by filtration.
So when
So
we put
can
the
be,
salt and then suddenly
yeah, so can be separated by filtration.
why it won't.
But in the true solution, you have to remember that particle size is very less. It is less than 1 nanometer, so you cannot separate it by this filtration or by using the filter paper. Okay, so what was the next question?
Three different
State
types of
Yeah,
different
water,
state
states
three
of
states of
different
water and
water.
states of
justify.
water. Justify. Okay, I think you have
So
correctly.
solid, liquid, gas, and then I justified how they transform from one another.
Due to
Yes,
change
Ex-
in
sir.
temperature.
You can say, yeah, I wrote
Sir,
that in the bottom, but I wrote like
So
condensation,
water,
vaporization,
it
sublimation.
under normal conditions exists in the liquid state, correct?
Yes, sir.
Yes, sir.
0 to 100 degrees Celsius, sir.
And when you just heat it to
0 to
100
99.
degrees Celsius, it gets converted to water vapor.
Sir, if you further heat it, it will become into steam, right, sir?
Exactly, water vapor. That means if you further heat it, it will become
Water
steam.
vapor is
Water,
Plasma,
steam.
sir.
the water vapor is also
That's
your
it.
steam.
Sir, is it okay if I wrote steam in that question
Yeah,
paper?
yeah, that's okay. That's okay. That's okay. So 0 degrees Celsius,
Water vapor.
it
So
will
it
become
becomes solid ice.
exactly. So
Ice.
this was the answer of this. What is the next?
Uh,
Hot
Hot.
Sir,
aluminum
hot
oxide.
aluminium oxide,
This
Al2O3
is the
is a...
question, sir.
Sir, we never learned this, sir.
We, I haven't given the example of this Al2O3. Okay,
No,
no
sir.
problem.
I don't even know
I will.
what it is.
Okay, no problem. I will tell it here. See, actually, whenever you have this hot aluminum oxide, it is known as alumina. Al2O3, it is known as alumina. You will remember that it is known as alumina. And it is used as this alumina, it is used as dehydrating agent.
Yes, sir.
Okay.
Yes, I got it.
It is used as a dehydrating agent. So now what is a dehydrating agent? It is
They remove
simply
white
any
water.
substance which removes water,
The
which removes
water of crystallization.
which
For
removes
water
H2O, water,
crystallizations,
through
right?
chemical change. So okay, I will write it here. That dehydrating agent removes water.
Sir, isn't it water of crystallization molecules?
No, water
No,
crystallization is
no, no,
drying
no,
agent.
no, 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 no. It is only H2O. It is only H2O. It is only H2O. It is not water of crystallization.
Okay,
It
sir.
becomes drying
I will,
agent. Right?
I will just give you the example. Dehydrating agent removes H2O from other substance by chemical change. So that means here is the chemical change.
Yes.
By chemical change. You have to remember this. I will just give you the example by chemical change.
So that means I can take washing soda or something like that and remove all
I
the
will, I
water.
will, I will, I will just give
Sir,
you the
will we get marks for this? Like, because like
what
we
you have
didn't
written
learn
here.
this.
So I
No,
wrote
sir, like I didn't
dehydrating
learn
agent.
and I just put hygroscopic substance just to attempt it, but we didn't know this thing, sir. So will we get marks? Like,
I don't know regarding this. Hope that you will get.
I
If
used
you,
my common sense because dehydrating means not water, right?
yeah, dehydrating means
When
which
we
will just,
dehydrate,
yeah, which will dehydrate. Okay, I will just give you the example. Just to see to this, we are having this ethanol, and you are just treating it with concentrated sulfur. Example of this, okay, dehydrating agent. You can also have another example of this dehydrating agent like concentrated sulfuric acid, concentrated H2SO4. So if I will just to treat it with concentrated H2SO4, what it will do? It will just remove water from this. Can you tell me, is there any
yes,
water of crystallization? Is there any water of crystallization here in this ethanol? No. But when
no,
it
it's
is
yes,
just
sir.
water, sir.
when when it is treated with this concentrated sulfuric acid, we get this ethene and we get the H2O. So where from this H2O came? Can you tell me where from this came?
The
Sir,
From
H2O.
H2 and
ethane.
O, sir.
Ethanol. From
Yeah,
No,
exactly,
H2SO4.
exactly. So that means there
Sulfuric
isn't
dioxide.
any water of crystallization. There is just OH here and here one H. It was CH3.
I said right, but this whole thing is ethanol.
Yeah. So that means whenever we have such a substance which will remove water from other substance by chemical change. So it is chemical change. Is it a physical change or a chemical change?
Chemical change,
It's a
sir.
chemical.
Exactly, it is a chemical change. So that is why this is known as dehydrating agent. This is your dehydrating agent. You have to remember this.
The next question.
Yes, sir.
What is then desiccating agent? What is the difference between desiccating? Desiccating also absorbs that absorbs actually moisture from other substance. So that means that will absorb water of crystallization, right?
Yes.
Yes,
That
sir.
means there will be not any chemical change, right?
Yes.
Yes, sir.
But yes, but here it will be the chemical change. Okay.
So can I tell the next one answer, sir?
Okay, tell me.
Hey,
Sir,
Nitish,
what
you
is the
just
effect?
took a leap of luck and like you put it either between drying
No, I
agent
use
and
my common
dehydrating
sense that dehydrating. When
Hey,
we get
drying
dehydrated, we lose water, some stuff, and then we get thirsty. I use that common sense and just tomorrow dehydrating because that we didn't learn.
How can Al2O3 not be a drying agent if
Because
like you
it's
didn't
not an
know?
example of any other three.
Well, Sir said he didn't give it in any other thing. Maybe he forgot to give that example in any other.
Okay, sir, I'll tell the answer. The second one. The effect of temperature of solubility of KNO3 and CaSO4. For
Yes.
KNO3,
Is this screen
temperature.
visible?
Yes, sir.
Yes, sir.
Tell me then here.
Yes.
So what is the next question? That is what is
So
the effect of temperature? We have studied this, isn't it?
Yes, a KNO3
Yes, sir.
temperature increases, solubility increases very high, and then
Exactly. Whenever we have this potassium nitrate and sodium nitrate, I have already told you that if you just increase the temperature, solubility will also increase, right?
high.
Yes, sir.
Exactly. Solubility will be
So
high.
when
Okay.
CaSO4, when temperature increases, solubility decreases.
Exactly. We have studied this in the last lecture, right?
Yes.
And I have
Yes,
also
sir.
given you one more salt. That was the Glober salt. Do you remember?
So it was anomalous solubility. When
Yes,
after
sir.
31 degrees Celsius, it will decrease. Solubility will start decreasing.
Exactly.
And
So what
that's
was the
what
salt?
it's a global salt. Sodium.
What
Glober salt, sir.
exactly? So what is the
Sodium.
formula of Glober salt?
So sodium carbonate. Sodium
That is sodium
carbonate dehydrate.
sulfate. It is
Sodium
sodium
sulfate.
sulfate decahydrate,
That's
right?
washing soda. That's washing soda.
Yeah, sodium carbonate, that is the washing soda. Sodium sulfate is the Glober salt, right? It is your Glober
Sir,
salt. I have to,
NaSO4 10 Na2SO4 10H2O, sir.
yeah. So when I have told that first of all, when we increase the temperature, solubility also increases. But after some time, that means after 31 degrees Celsius, if we just increase further temperature, then solubility will decrease. It shows anomalous behavior, right?
Yes, this gap is called
Yes,
transition
sir.
temperature.
Sir, I
That
have a doubt, sir.
okay, tell me.
Sir, what is cost? Did we learn that?
What?
Caustic soda,
Caust-
CaUSTICS.
Caustic soda is your sodium hydroxide. We have learned this. Caustic soda is this one, and quicklime is your calcium oxide, and slacker lime is
CaOH.
whole twice. Yeah, this is quicklime, this is your slacker lime, and this is your caustic soda. NaOH.
Yes, sir.
Okay, what is the next question? Question is here. What is efflorescence? Give an example of efflorescence substance.
You want to answer?
We have
Can I
studied,
say, sir?
right?
Can I say, sir? I'll say.
Okay.
Process
Tell me.
in which when sir,
Tell me.
process in which when bruh, be quiet. Sir, it's the process in which when a salt is
Mhm.
exposed to like air, it loses its water of crystallization, sir. Molecules.
Exactly. Whenever any substance it is exposed to air and it just loses the water of crystallization, so they are known as efflorescent substance, right?
Example,
Sir,
sodium chloride.
example is Glauber salt, sir.
Exactly.
Washing
Below
soda.
the salt, you can give the example. For example, if you are having this Na2SO4 into 10 times water, if you just expose it to the dry air, what will happen?
It will
It,
become Na2SO4.
it will become just Na2SO4, yeah. And 10 water molecules, they will
Yes.
just get removed.
Yes,
10
sir.
times H2, right?
Even washing soda is an example, sir.
Exactly. Washing soda is also sodium carbonate decahydrate. When you just expose it to the dry air, it will also lose its water of crystallization.
Yes, sir.
It will become Na2CO3 and 10 times H2, right?
The next one I didn't
So
know.
we have already studied it in the class. What is actually
It's
this?
so simple. The next one. Next one is so simple.
Okay, yeah. What is the next one? 1 mole of sample of
Sir, can I say,
hydrated
sir? Can
salt.
I say, sir? Can I say,
Okay,
sir?
tell me.
Sir, the answer is D, sir. Na2S into 9H2O. Sir, it's
Ex
because
exactly.
Sir, it's because we know that one H2O is 18 grams,
Exactly.
molar grams, and 9H2O is 162 molar grams. So in all the options, we see that Na2S is common. So I took 9H2O, sir.
Exactly. See. Okay, I will tell you how to solve it in detail. For example, what is the mass given here? So can you tell me again?
162 grams, sir.
Exactly, 162 grams, right? So this is the mass of water of crystallization. So water of crystallization, you know that water of crystallization simply means water molecules. Now you have to check whether there will be 2 water molecules, 3, 4, 5, or 9. So that means simply you know that the molar mass of water, it is 18 grams. So you will just divide this 162 gram with the 18 gram. You will get the answer.
Yes.
For example, 2 9s are 18, and similarly 2 81s are 2 8s are 16, and 2 1s are 2. So it will be 81
9
upon
by
9.
1.
So 9 ones are 9, and 9 nines are 81. So 9. So water of crystallization will be 9. So it is only in the option D, right?
Yes, sir.
Yes.
Exactly. So 9 water of crystallization, they are only in the option D. So this will be the correct. Okay, then what is the next? Solubility of NaCl at
Wait,
40
can you
degree.
go back?
Yeah, I will
So,
go back.
sir,
What is
actually,
next?
they did mention. Sir, this statements means that in 100 grams of water, 36.5 grams of NaCl is able to dissolve in 40 degrees Celsius.
Wrong.
Exactly,
Maximum.
exactly.
No, you have to
If
include the
you
word
if you
maximum.
if you just remember, I have told you that what is the
35 was,
solubility of
36.
NaCl? What is the solubility of NaCl?
So 36 grams and
36
25 degrees Celsius.
36 grams and 25 degrees Celsius.
Exactly,
6.5.
36 gram in 100 gram of water, exactly at 25 degrees Celsius. Now the question is here that if it is now 36.5 grams, so that means it will be also in 100 gram of water, right?
Yes,
sir.
sir. But temperature will
And
increase.
exactly, temperature is here increased, and I have already told you that if we increase the temperature, solubility will also increase. So that's why it is 36.5, right?
Yes, sir.
Yes, I have told that in case of NaCl, if we just increase the temperature, solubility will also increase, but it will not increase too much, right? I have told
Sir,
it
I
there.
wrote that
Sir,
uh,
I'm not confident of
36.5
it.
grams
Okay.
of 36.5 gram of NaCl requires a minimum of 100 grams of water at 40 degrees Celsius to dissolve itself completely.
Exactly, this is correct. So you can write it just like this, that it means 36.5 gram of NaCl, it can be dissolved in 100 gram of water at 40 degrees Celsius, right?
Yes, sir.
Yes.
Okay, what is
Sir,
the
next.
next question?
The next one is called
Sir, is
Hydrated
it
calcium
water of
sulfate.
crystallization?
Exactly, has the formula of
Okay.
calcium sulfate into 2 times water. What is the name given to the water
calcium
molecules
sulfate.
present in the salt?
It is Epsom salt.
Water of crystallization.
Exactly, these are the water of crystallization. So this is also correct, but somebody has written it just like this. Okay, I will tell you.
What am I supposed to write in this?
You are
supposed
supposed
to
to
write
write.
what, like what's in
You are,
H2O? Is it just
you
water?
are,
Is it just in like liquid form, like water form, or is
you,
it in
I will tell you, you are just supposed to write that what are these, what is the name given to this. So this is you, simply water of crystallization, right?
Yes.
yes?
Yes,
But,
sir.
but also you will remember that if somebody has written this as dihydrate, so this is also correct.
Oh yes, Appada, I wrote diet. That's correct.
Exactly, this is also correct.
Okay.
Can I
Hey,
write
mute
calcium
yourself, yeah.
sulfate dihydrate?
Yes, somebody, there is some noise coming, so just mute yourself.
Yes, sir. Can
Yes,
I
sir.
write
Yes,
calcium
sir.
sulfate dihydrate?
Perfect.
I still get marks.
Exactly, these water molecules are known as water of crystallization actually, but if somebody has written as dihydrate, it is also correct, because if it was just like this, calcium sulfate 10 times H2O, then you will
Sir, I
write
wrote
it
the
as
whole.
deca.
Sir, I wrote the whole
Dihydrate.
thing, sir. I wrote it's calcium sulfate dihydrate, and
Exactly.
brackets I wrote Epsom salt. It's Epsom salt only, sir.
No, this is not your Epsom salt. Epsom salt is different. I have told in the last lecture.
What is
Epsom
that?
salt,
Yes.
that is your
Epsom
magnesium
salt is magnesium. Oh, magnesium salt.
sulfate 7 times water.
Hexahydrate.
Okay, so I hope you have corrected it. So this is your simply water of crystallization, or you can also name it as, you can also call it as dihydrate, because there are two water molecules. Okay. So next question is, what are
So
drying or
desiccating
desiccating
or
agent?
drying agents, sir.
Okay, so can you now
So
just tell?
substances which remove moisture from other like substances. Examples are CaCl2 and SiO.
Yeah,
I
exactly.
will
So they
say
are,
here
see,
SiO2, SiO2.
so as the name indicates that they are drying, so that means they will just remove moisture. They will just absorb moisture from other substances. Okay, I will write it.
So the next question is no one understood it. Maybe.
So drying agent, you can simply say drying or we have already studied in the class, right? Desiccating agent, isn't it?
Yes, sir. Yes, sir, we did, sir.
Okay, so desiccating agent, it simply absorbs moisture from other substances.
Yes, sir.
Absorbs
So
moisture
what are
from.
you supposed to do for the next question, sir? I don't get it.
Okay, I will tell
When
you.
it's exposed to air, it loses moisture, but some
So
does not.
drying or desiccating agent, right?
Yes, sir.
Absorbs moisture from other substances. So I have already
Yes,
given you
yes.
the example. Okay, let's see the next very important question. That is actually, among the following salt, right, which increases in weight? That means you have to tell which will just increase its weight, or which will decrease its weight, or which will not change its weight when exposed to atmosphere. It is very easy. So see, any salt which is exposed to the atmosphere, if it absorbs moisture, that means if it absorbs moisture, its weight will increase. If it loses its water of crystallization, so that means it will decrease its weight. If it neither
Yes,
loses
sir.
nor it absorbs moisture, so that means its weight will remain same.
Oh, yeah.
Correct?
So no one in the no one actually got the full mark of this question. So
Okay, no.
Okay. Sir, so like
know what you have to do, sir,
example
but
number
still-
7, sodium hydroxide, it will absorb water when really when is kept in atmosphere because
increase in weight.
it's
It
a
is
deliquescent substance.
exactly. It is a deliquescent substance, so that's why it will absorb
It's
moisture. So its weight will increase. Correct?
found out it, sir, but I put I also have the answers here, but still I don't know if it's correct.
Okay, no problem. Let us start with the first one. First one is what? What is the first one?
Green vitriol. Sir, it's FeSO4
I have
7.
already told you what is green vitriol, right?
Yeah, it is
Green vitriol
FeSO4.
is your
Yeah,
FeSO
yes, sir,
It's
it's FeSO4
FeSO4
7H2O.
heptahydrate or
7 times water.
I was right.
Heptahydrate.
I was right.
Heptahydrate. Okay, now
Yes,
tell
sir.
me that when it
Ferric
is
sulfate.
exposed to the dry air, what will happen?
Sir, it
Sir,
will form. Will
Dry
form
air.
some.
That
sir,
means
it will form like a
it will just
crystal.
lose its water of crystallization. Got it?
Yes, sir.
Oh, so it
When
becomes
it will
lighter.
lose its water of crystallization, so that means its weight will decrease simply.
Sir,
It is
uh,
Got it?
Sir, but you didn't give that in the examples of deliquescent substance. So like I didn't know if
It was
it
just
will lose.
concept based. You have to just think. If you just have a little bit thinking here, you can solve this one. You you have been told that when any salt is exposed to the air, what will happen to its weight? It is simple that if it absorbs moisture, its weight will increase. If it loses its water of crystallization, so that means weight will
Sir,
decrease.
that means every salt in this question is increasing in weight.
No,
No.
how it can
See,
increase?
we are
It is decreasing here in case of green withdrawal. So what is the next?
Oh, sorry,
when your
decrease
eyes
in weight.
It's
Decrease.
soda
Ne-
ash. Soda ash.
Okay, next is soda ash. Now tell me what is soda ash?
know what is
Anybody knows what is soda ash?
Sir, I asked
soda.
Pongwell this.
But-
I asked you this, and you're like, no.
That's why I was
Hey,
telling that something
It
is
is
he
the
asked
sodium
me if
No,
the
no,
carbonate.
question was wrong, sir. And I said, no, it's
I-
not wrong. I know there's something called soda ash, but I just don't know what it is.
I never heard something called a soda ash, sir.
Okay, from now
Not my
on,
fault.
you will remember that it is your sodium carbonate. When there is no any decahydrate, when there is decahydrate, that is washing soda. When there isn't any decahydrate, it is known as soda ash. Got it?
what is it?
Yes, sir.
Now tell me that when it is exposed to the air, what will happen?
Sir,
It
it
will
will
absorb.
gain weight because
Exactly, it will just absorb moisture. It will become Na2CO3 into 10 times water. It will absorb moisture. So that means its weight will increase.
I wrote remain same for everything I do in numbers.
Weight will increase. Now tell me
that's
that of
actually
next.
smart, because you can get at least some marks.
Yeah, that's
Okay, now tell me what is the next? Next is
What is smart?
magnesium
Magnesium
chloride.
chloride, sir.
Okay, what is the formula of
Magnesium
magnesium
chloride is
chloride?
MgCl2.
Sir, MgCl twice. No, MgCl2.
Okay, now tell me that if it is exposed to air, it will also absorb moisture.
Yes, sir.
Yes, sir, because it is
Sir,
a
basically everything with
drying
water
agent.
or water of crystallization will lose them. The ones which do not have will gain.
Exactly, simply, yeah. Whenever we are having any salt which is having water of crystallization, so that will lose. And if any salt is not having, that will gain. But but not all salts will absorb. Some salts only absorb. So you have to remember which will not absorb. I will tell you the example. Yeah.
What are crystallization molecules? But it doesn't lose.
Washing soda will lose because it's
Yeah.
it has
If we are having washing soda and we are just exposing it to the dry air, then it will lose its water of crystallization. You have to remember it.
yes, sir.
You are having here soda ash. So soda ash, when it is exposed to the air, it will absorb. So when it absorbs, its weight will increase. Okay, now tell me what is the next after magnesium chloride?
Concentrated sulfuric acid.
Okay, you now know this concentrated sulfuric acid. So can you now tell me what it will do?
Sir,
When it is exposed to the air,
sir, it will gain. Sir, it will gain. Will it? Sir, because
No,
concentrated means it has
it
more
will
amount of
remain the
solute
same,
and
I
less
think.
amount of.
see, I have
It will
told you
remain the
that
same.
whenever we have concentrated sulfuric acid, if there is some concentrated means there is some moisture in it, right? There is some water in it. So when it is exposed to the dry air, it will actually lose it some water. Actually, that vaporizes. So that
Oh
means
my
here
God.
its weight will decrease. Weight decreases here. Now tell me next.
The sodium hydroxide. Sir, increase.
It is your sodium hydroxide, exactly.
It will increase.
Sodium hydroxide. So I have
Washing
told you that
soda will
this is your
decrease.
deliquescent. Deliquescent means it will absorb moisture, right?
Yes, sir.
Yes,
So
sir.
when it
Yes,
absorbs
sir.
moisture, its weight will increase,
Will
right?
gain weight. Yes.
Exactly. Okay, tell me next. What is the next one? Sixth.
Glauber salt, sir.
Washing soda will decrease.
It will decrease.
Washing
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 soda and
soda will
Glauber salt.
increase.
Yeah,
And what is the
sorry.
next?
Washing
Is what?
washing soda and Glauber salt will decrease, sir, because they have water of crystallizations.
Common salt will remain the same.
Because whenever I keep common salt on
It's
table,
common
nothing happens.
salt.
So washing soda, we are having Na2SO4. Okay, we are having sixth one is our washing soda, that is sodium carbonate decahydrate. And we are having here also decahydrate. So that means they will lose their water of crystallization, so their weight will decrease.
Decrease.
Exactly. Okay, next is what?
Hey, Nitish, you're unlucky. Most of them got decreased. You wrote everything increased, right?
Next is your common salt. Okay, tell me that of common salt. It is now very important.
None of them remains.
Sir, it will remain the same, sir.
Yes, exactly. This will remain same. NaCl, when it is exposed
You
to air,
got
neither it
one.
will lose
You
nor
got
it
like
will.
half a
So it
mark.
will remain same. Got
Yes,
it?
sir. Yes, sir.
Yeah.
Most rare people put it in sambar.
Okay, what is the next question?
Ferric chloride, sir.
Which test will you carry out to find out if a given solution is
Hey, no,
saturated or
there's two more,
unsaturated?
11
Hey.
and 12, sir. Ferric chloride and sodium
Oh.
chloride.
Pankaj.
Oh.
Okay,
You
I
didn't
will
see that
first.
in the exam, right?
Sir,
Pankaj
ferric
becomes
chloride
calm.
will gain, sodium chloride will gain. Wait, will they? Sir, chlorides are moisture, right, sir?
No, chlorides are salts.
I'm telling.
Is this secret
not,
visible?
not. I'm talking about the liquid chlorine. The chlorine is like moisture, right?
Chloride and chlorine is liquid. It can remain. It can be in all states, except I don't know, gas. I don't know about gas, but
I don't.
liquid and solid.
At this point, I don't know that.
Okay, now tell me here.
Ferric chloride. So I hate this question, sir. This question should not exist.
Sir,
What?
it's decreased a lot of marks.
Ferric chloride. No, this whole
Yeah,
question
ferric chloride. So what will happen to this ferric chloride?
same.
Sir, but it will remain same. No, it will lose. It will lose. It will lose.
It will gain, sir.
Mm-hmm. So this you are having FeCl3, right? FeCl3, ferric chloride.
Yes, sir.
It will actually absorb moisture and its weight will increase.
Sir, Kongwell answer the one thing we both didn't answer and say. Found it out.
Okay. So sodium
What?
chloride, it will remain same. Okay. Yeah. So now tell me that.
Same. Oh yeah. Okay.
Okay, which test will you carry out to find out if a given solution is saturated or unsaturated or supersaturated?
Dilute and then see if
So
it
first
dissolves.
I have a saturated solution and I
Mhm.
put, let's say I have a beaker of water of 100 grams and
Okay,
I
let's
put
let's
36
take.
gram
Hmm.
and I put some NaCl in it. If the NaCl is still present at the bottom, it is a saturated solution. If the NaCl is mixed with the solvent, it is a unsaturated solution. Supersaturated, I don't know.
When it gets
Okay, okay.
precipitated. When
What
it
is
gets
I
So
don't know.
simply you will write that whenever you have to test
How can I see if a thing gets
whenever you have to test
precipitated?
this, you will remember that you will just add salt. Add salt like NaCl, right?
Yes, sir.
And when this NaCl salt you are just putting in this solution, and let's say it dissolves in it. Let's say it dissolves in it. So that means it is unsaturated, right?
Unsaturated.
And if you are dissolving this NaCl salt, it gets deposited here. That means it doesn't dissolve anymore. So it is your saturated, right?
Yes, sir.
Now, no. See what you have to do here. If you just cool down this, if you just cool down here, and NaCl just crystallizes and comes out in the form of crystals here. So that means it is your supersaturated.
I wrote when the salt, I mean when the solution is cooled down, the salts
Hmm.
get precipitated and that forms supersaturated solution. Is that
Exactly. That is right. That's right.
Yes, sir.
Okay, tell me next question.
So,
Sir, what causes permanent hardness in water? Sir,
So I hope
chlorides and it's the chlorides and sulfates of calcium and magnesium.
just like
exactly.
salts of calcium and magnesium.
You can just write the salt of calcium and magnesium simply. That's also correct. If you write the calcium chloride, calcium sulfate, that is also correct.
So
And if
what
you write
he
the
was
calcium
wrong,
bi,
sir. What Shankar brought was wrong, sir. He didn't mention about bicarbonates.
yeah, calcium
Bicarbonate is
bicarbonate
temporary
also
hardness,
causes.
da.
Hey, but it's also permanent
Sir,
hardness, sir.
Okay.
sir,
Here it is permanent. It's
bicarbonate
permanent.
is
So
temporary hardness, right, sir? You
exactly,
mentioned
exactly,
it under
Only
exactly.
temporary
bicarbonate.
hardness.
It's all three are also
Yeah,
permanent.
only bicarbonates is temporary thing.
Exactly. So you will just write here calcium chloride or calcium sulfate because it is given permanent hardness. So or you can also write the calcium and magnesium chlorides and sulfate. Okay, calcium chloride, calcium sulfate, or you can also write magnesium chloride, magnesium sulfate.
Okay.
Okay, what is the next?
Advantages.
One
One
advantage
advantage of it does.
So I
It
told
does
that
not
with
produce
this
lather, sir.
hot water, it is tasty, right?
It
It
contains minerals which is good for our body when you drink.
exactly. It also contains minerals. I have already told it. It contains minerals, so that are very essential for our body, right?
Sir, it does not produce lather when you don't want lather to be produced.
Hey, how is that an advantage, sir?
That is not
When
the
you don't
advantage.
want lather to be. So when you
Ad-
don't want lather to be
This is the
produced,
stupidest thing I've ever
See,
heard.
see, actually, it is given that state one advantage of using hot water. So when you just use this hot water, so that means you are just taking the minerals indirectly. So minerals are very good for health, for the growth, for the development, right? Okay. Give one
I
equation
got
for
that
the
wrong.
removal of permanent hardness. I have already
No,
told
sir,
this in the
calcium carbonate plus no, wait,
Sir,
not calcium carbonate.
sir,
Sir,
magnesium
calcium
sulfate
chloride
plus
plus
NaCO3 gives NaSO4 plus MgCO3.
so that means simply you are taking it with treating it with washing soda, right?
sir.
Sir, because water crystallization doesn't make a particle.
Yeah, so it will
Sir, I
become
have
a
to balance
calcium.
it. It's 2 NaCl, sir. This time.
Exactly, two NaCl here. Correct.
But you didn't.
Okay, tell me
Hey,
next.
we both said the same thing, but different equations, sir.
I didn't say anything.
Okay,
Yeah,
what
that
is
is also
basic
correct.
difference? Okay,
If you are just
yeah,
taking magnesium chloride, then reaction that's also correct. If you are taking the calcium sulfate or magnesium sulfate, then they are also correct. You can take any reaction. You have to give
what is the
one
basic
equation.
difference in terms
Sir.
of function?
Exactly.
Sir, I
What
didn't
is
know this, sir. I didn't know
Hey,
this.
no, first question, first. What is the basic
okay?
difference
We
in
have
terms of
studied what is actually soap, but we have not discussed the detergent.
soap
Okay,
is
I
what you use to
No, sir,
like
we
wash our
didn't
clothes, and
discuss
detergent
detergent,
is
sir.
to wash our bodies.
yeah, exactly.
We
Detergent, I
know
think
that,
it has,
but I. Bruh.
so they are just
Basic
soaps or the
difference, sir.
sodium salts of higher fatty acid, right?
Yes, sir.
You're very smart, Nitish.
Higher
Some
fatty
people
acid.
know. Yes, sir.
Okay, then what is the detergent? Can you tell me what is detergent? Anybody?
Sir, it's used
Sir,
to clean clothes, sir.
it's
But
used to
what
clean
it
No,
body,
is actually?
just to
It is
clean
the
used to clean our
us.
sodium
body,
salt of.
detergent.
Just
It
now
is
you said,
the
hey,
Detergent
sodium
is
salt of
body, yeah. Soap is
alkyl
body,
yeah.
bro. Detergent.
alkyl
Sir,
sulfonic
No,
acid.
sir, I
Nitish said
told
detergent is
alkyl
body.
Exactly, this is correct.
sulfonic acid in class. You said don't learn it, sir.
So the functional group here it is the sulfonic acid, and here it is the fatty acid, higher fatty acid.
Sir,
Correct?
we use
Isn't
detergent to clean
alkyl
our
latex
bodies, right?
sulfonic acid?
Yes, we use these detergents are preferred over soaps because detergent can be used in hot water also. So can be used in hot
Isn't
water.
it alkyl latex
Yes,
sulfonic
uncle, we
acid?
use detergent.
It is used in hot water also. Soaps cannot be used in hot water, right?
Soap
Yes,
is for
sir.
washing
They
clothes, right, sir? But
And
we
in
detergent.
acidic water. Also in acidic water we can use the detergent but not the soaps.
But isn't
Have-
it alkyl latex sulfonic acid?
It is alkyl sulfonic acid. Alkyl is actually represented like this or, and then it is
C4.
Sir, RCOO,
it is
That's
Na, or
different.
sulfonic,
K, sir.
That's different. That's different. That's
sulfonic
soap.
acid.
Oh, that is.
So this is
Oh,
your
that is
this
soaps.
is
That is soaps. That is soaps.
Yes.
this is your detergent, right?
Yes, sir.
And soap is just represented like this. That is your RCONE.
Sir, I didn't know. Once again, sir, but
Arcuna.
I mean, alpha-sulfonic acid. I thought you have to like,
Alkyl sulfonic acid. Yeah, tell me.
sir, I wrote it as.
See, whenever we have this SO3, it is known as sulfonic.
Yes, I wrote R
Thank you, sir.
H4
Okay, what is the next?
SO3 and sir, in a beaker containing hot water, rub soap and detergent in which beaker formed lather will be formed. What is the reason for lather
Scum,
formation?
scum will be formed when you are having soap, and leather will be formed when you are having the detergent, right? Because it is hot water. I told
Sir,
that in hot water, soaps do not
hot
work.
water. Only detergents work.
Yes, exactly. So that means scum will be formed in case of soap, and leather will be formed in case of detergent, right?
Yes, sir.
Yes, sir. So what
Okay.
is the reason for lather formation?
Reason is actually I have told it. For example, if you are having this, let's say this is your soap, that is RCOONE, right?
Yes, sir.
And when it actually it is dissolved in water, actually there is micelle formation. Actually, it is studied in higher classes, micelle formation. So that means actually what happens, there are two parts in the soap. One is your polar head, another is your tail. So I will just write it like this: RCOO.
So what?
Okay, I will tell you, this is known as polar head. This just acts as a polar head, and this R acts as a polar tail.
What is a polar okay.
Don't ask questions. I have 1 more minute.
Polar means it is actually charged. It is actually charged, and this is your non-polar tail. Non-polar means it is not having any charge. This polar head, it actually dissolves in water. It dissolves in water, and this non-polar tail, it dissolves in the dirt or the oil particles, which we have to remove from any cloth, right? So this results in
Yes.
the formation of this hole is known as micelle formation. So it actually forms the leather. So this is the reason for leather formation. You can write like this, that in case of soap, there are two parts. One is your polar head, another is your non-polar tail. This polar head, it dissolves in water, and non-polar tail, it dissolves in the dirt or the oil particles, and then it forms micelle. So this results in the formation of leather. Okay, now tell me that in case of, what is the difference between temporary hot water and permanent? I think we had discussed it, right?
Hard water is caused due
Yes,
to
sir.
bicarbonates of calcium and magnesium. Hard water is
Exactly.
permanent is caused because of salts of calcium and magnesium. So we have to speed run the
Right.
questions.
Balance the
Temporary
chemical
hot water needs temporary hot water just needs boiling to be removed.
exactly.
Permanent hot water
Then
needs
hard water needs
baking
washing
soda
soda.
and other
Baking soda, washing
Baking
soda.
soda.
sorry,
Washing
sorry, washing
Baking
soda.
soda.
Sorry.
Exactly. Okay, no problem. What, write two difference between drying agent and dehydrating agent.
You missed one question, sir.
So what?
Drying means that it will
Sir,
just remove the moisture, right?
You missed one question, sir.
Yes,
You
sir.
missed one question. You missed
There
one
is no
question.
any chemical change, but in case of dehydrating agent, there is chemical change, right?
So
Okay, let me.
drying
Okay,
agent is only for removing moisture, but dehydrating is to remove that water, sir. Not
exactly. Dehydrating means it removes water, that is H2O. It removes H2O from any substance, that is by chemical change. So I will write it here: removes H2O by chemical change, right?
yes, sir.
And in dehydrating, you can write, in drying agent, you can write what? It removes,
Sir, it removes moisture from other substances.
yeah,
By
exactly.
physical
It removes moisture from other substance without any chemical change, right?
yes, physical
Sir.
Yes, sir.
Without
write this question.
any chemical change.
And write the last one.
Yeah, I
What is the
didn't want
last?
dehydrating.
So this is your drying agent. That means it removes the moisture from other substance without any chemical change. But this dehydrating, it removes water by chemical change. For example, you are having here concentrated H2SO4, right? And this drying agent, it is like your calcium chloride anhydrous, quicklime, etc. Okay, what is the last question? So I think this was the last,
No, we
right?
can't. Yes, sir, that was the last.
Yes, sir.
Okay, so we have completed this
Getting a lot of marks there.
paper. So next chapter which we are going to start, that is your chemical bonding, right?
Yes.
No, sir.
No, sir.
That we will
No,
start in the
sir,
next. Yeah,
sir, I feel like it's enough for this term, and we can just practice in
exactly,
these
exactly.
three
Okay, let's
chapters for our exam,
exactly.
like
So
for
in
our
the next,
term exam.
we will start from the next chapter. I hope that you will go through that, and wish you all the way best. Have a nice day ahead.
Thank you,
Thank you,
sir. Bye,
sir.
sir.
Yes, sir. Thank you, sir. Bye,
Bye.
sir.